Now, when we're taking fractions and we're changing them to decimals, we have to remember that fractions are really division problems. 1/5 is really 1 divided by 5. I can do that. I just have to place a decimal in my answer and add some zeros. 5 will divide into 10 2 times. That's the end of my problem. What is it? It's really, 1/5 is really 0.2, or that would be 2/10. Let's look at example 2. Example 2 is 13 divided by 25. Well, let's place a decimal and a zero. We may need more zeros, but we can always add them later. 25, I'm thinking quarters here. 25 won't go into 13, but it will go into 130. I would need 5 quarters would be $1.25, so 5 times 25 is 125. I subtract. I have 5 left. I'm going to bring down another 0. 25 will go into 50 2 times, and that's my answer, 0.52. Example 3, 5 divided by 12. Place the decimal, put some zeros down, and 12 will go into 50. Let's try 4. 4 times 12 is 48. We'll subtract, bring down another 0. 12 will go into 20. No, just one time. I'm going to multiply and subtract and bring down another 0 here. And 12 is going to now go into 80. Let's see, 6 times, I believe. 6 times 12, well, I think that's 72. And I subtract, and something strange is happening. I got another 8. Therefore, I'm going to be doing the same thing I just did. I'm going to be saying 12 into 80. Well, of course, that's going to be another 6. And it's going to be 72, and I'm going to subtract, and I'm going to keep on going. And as you can see, this will never stop. This 6 is going to repeat itself over and over and over again. It'll never end. So my answer is going to be 4.416, and the 6 is going to repeat. I'm going to draw a line over the 6, the number that repeats, just to show that it repeats. That's how we represent it, and I don't have to keep dividing once I find repeating digits. Example 4 is a negative 1/3. It's going to be a negative when I turn it into a decimal too, so I'm going to write that down so I don't forget. I'm going to say 1 divided by 3, put my decimal, place my negative sign up there, and 3 will go into 10 3 times. 3 times 9, subtract, and look what's happening. I also have found another repeating decimal. So all I have to do is write my answer as a negative 0.3 and draw a line over the digit that repeats, which the 3 will repeat, 0.33333 forever. Example 5, let's look at that and say the problem is 7 divided by 11. Put a decimal, add some zeros, place the decimal in the answer. 11 goes into 70 6 times. 6 times 11, 66, subtract. 4, bring down a 0. 11 goes into 40 3 times. 3 times 11 is 33. Subtract, bring down another 0. 11 goes into 7. Wait a second, this looks like something I've done before. Hang on. 6 times 11, 66. When I subtract, I end up with 4. Bring down another 0. That looks like 3 again. This is going to keep on going. This time, 2 numbers are repeating, not just 1. So when I write my answer, I'm going to draw the line over both of those digits that repeat, and that's how I represent it as 0.63 repeating. Now, what about a mixed number? I want to represent it as a decimal. I don't have to change it to an improper fraction and do division like that. I can just say this part of the number, this whole number part is going to be 4 point. Now I need to decide what is after that decimal place. That's when I'm going to take 7 and divide it by 8. I'm going to just look for the decimals. There's my decimal, add some zeros. 7 will go into 8. Well, 8 times 64, subtract, and that's going to be 6, bring down another 0. 8's going to go into 60, 7 times. 7 times 8 is 56, subtract, have a 4, bring down another 0, 8 goes into 40 5 times, and that's the end of it. So I have the whole number part, which was 4. I have the decimal part, which is 0.875, so I'll put them together. My answer is 4.875.